Hey class, Mr. Houston here, back and better than ever with another exciting episode of Geometry Notes. Today we are going to be talking about parallel lines and transversals. If you remember from 3-1, parallel lines were lines that do not intersect and are coplanar, and transversal was any line that intersects two or more lines at different points. So today we learned all those corresponding angles. We learned about alternate interior, alternate exterior, consecutive interior angles. All those we're going to be talking about again today, and what kind of special properties they have when they're dealing with parallel lines. So the very first thing we're going to talk about is the corresponding angles postulate. Hint, hint, I would add this to my postulate page. Okay? Basically, all this is stating is that if you have two parallel lines cut by a transversal, corresponding angles are congruent. So in this picture, 2 is congruent to 6. If they're in corresponding parts of the same line, or corresponding parts of two different lines, they are congruent. So our first example deals with that, and it asks the measure of 3 of the angles in this picture are 120 degrees. We need to identify those angles. So if we look here, 120 is in this position here. So if I go to the next parallel line and look, we're looking at the top left-hand side of that line. We would say that 5 would be a corresponding angle. So angle 5 would have 120 degrees. And we'll just say that's by the corresponding angles. So there's one of the 3. We also know, hopefully by now, that when two lines intersect, okay, so I have a line here and a line here, they create, remember, it looks like a V, vertical angles. So 120 degrees would also go down here to angle 4. We would say angle 4, that would be by vertical angles. And again, since we now know that angle 4 is 120 degrees, we can look at the bottom right-hand side of this line over here and see that angle 8 should be 120 degrees. And angle 8 would be 120 by corresponding angles. So again, we would only have to give you with parallel lines cut by a transversal. Remember that little arrow there means parallel. Cut by a transversal, we would only have to give you one angle measure. You can figure out the other 7 using vertical angles, using linear pairs, whichever method you want to use. There's lots of different ways to figure out those 7 missing angles. All right? So, some more theorems to add. Like I said before, we were talking about alternate interior, alternate exterior, and consecutive interior. Alternate interior angles and alternate exterior angles, they're congruent. So interior, they're on alternating sides of the transversal. They're in between the two parallel lines. They are congruent. Alternate exterior, they're on alternating sides of the transversal. On the outsides of the parallel lines, they are also congruent. The only one that's different than that is when we get down here to consecutive interior. They are in between the parallel lines, they are on the same side of the transversal, and they are, this little special word right here, they are supplementary. So that means that they are going to add, so angle 3 plus angle 5, add together, that's a plus sign, to equal 180 degrees. We're going to use all of this. We're going to do a little more algebra with stuff, more than we've done in the past here. But we're going to use all of these theorems in order to determine angle measures. Okay? So let's go ahead and flip over to the other side there. And let's take a look at example number 2. So we're going to use the properties of parallel lines to determine the value of x. So the very first thing here is we're going to look at 115 and where x is located. And do these fall into any of the theorems that we've used so far? Hopefully you're answering no, they do not. So we need to determine some other angle measures in order to solve for x. Doesn't matter to me how you want to do this. There's a number of different ways. One way would be to see that x plus 5 and 4 would be consecutive interior angles. So we know that those two added together would equal 180. We can also see that 115, and I'm going to start labeling this here because I think it's just going to be a lot easier. So those are vertical angles, so this would be 115. I also can see here that 115 and this angle measure right here are corresponding angles, so this would also be 115. So I have two different options I can use here. Actually, I'm sorry, we have three, because this 115 and this one out here would be alternate exterior angles, again making this 115 degrees. So any way you want to do it, we have three options. Basically, your options are to add two angles together, set them equal to 180. So I'll just simply say 115 plus x plus 5 equals 180 degrees. We'll combine our like terms. We'll subtract 120 on both sides, and we'll get x in this case is going to be equal to 60. Okay, so you're still kind of using your theorems and postulates here. You're just now using them in order to kind of solve some algebra. So kind of getting back to what we like to do. Okay. Speaking of things we like to do, example number 3 happens to be a proof. Okay, we're going to prove that two lines that are cut by a transversal, then the pair of alternate interior angles are congruent. So I've drawn, or I've copied a picture here for you. Two parallel lines cut by a transversal. We're proving that alternate interior angles are congruent. Okay, so I've given you the statements here. The first one, per usual, is always our given. We know that P is parallel to Q. Again, try to remember those two lines up and down like that mean parallel. Angle 1 is congruent to angle 3. How do we know angle 1 is congruent to angle 3? Remember, they're on the same side of the transversal. They are they're on the same spot but on the different lines, so that makes them corresponding angles. So reason number 2 here is corresponding angles. Then if we look here at 3 and 2, they are also congruent because of what? Remember, two intersecting lines kind of creates that V there. Okay, they would be vertical angles. Okay, and then hopefully as you look here, let's read this again. 1 is congruent to 3, 3 is congruent to 2, therefore 1 is congruent to 2. Hopefully you see that they have the 3 in common, therefore we would have 1 is congruent to 2, and that would be the transitive property. But remember, we have 3 transitive properties. We are talking about angles, and we're talking about congruent angles, so it would be transitive CA. So there is a 4-step proof to prove the alternate interior angles theorem. Proofs aren't really going to go away. We're just going to be doing them less and less, but we still want you to be thinking logically about how those work and how to do them. And lastly, just to brighten up your day, a little real-world problem, easy for me to say, right? Talking about sunlight, drops of rain, and the rainbow. Okay, so if you can see here, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. The process is what makes a rainbow. For violet light, so if you remember your colors of the rainbow, for violet light, the measure of angle 2 must equal 40 degrees. So if I'm looking at it, I got to look at it from a 40-degree angle. So we have to figure out what the measure of angle 1 is. So we have this line right here and this line right here that's telling me that they are parallel. So if I have an angle measure here, let's go ahead and mark it so we know this is equal to 40 degrees. So if I have an angle measure there and I'm trying to find a alternate angle on the other side of a transversal, I'm alternating sides. I'm in between the parallel lines, so they're alternate interior angles. So what do we know about alternate interior angles? That's right, they are congruent. So the measure of angle 1 is 40 degrees, and we would say that is due to the alternate interior angles theorem. Okay, So again, a lot more algebra today, not so much logical or proof-based, but just some more theorems we need to get added to our postulate sheet, and some more algebra that hopefully that will raise your confidence a little bit here as we move forward with parallel lines. Have any questions, bring them with you to class. Have a wonderful day.